My name is Abdelkader Mizgani. I'm working at the Norwegian Meteorological Institute and will be presenting the Annotated Atlas together with my colleagues, Hans Christian and Bart, who is actually sharing the presentation. So I will only introduce the Annotated Atlas. I haven't done that much for most of the developments behind the Annotated Atlas has been done by Hans Christian and Bart, but I will only introduce the topic and then leave it to Bart to continue with the details behind it. Next slide, please. So the outline of our talk is, as I mentioned, about the Annotated Atlas, the web application that has been developed at MET. The first thing I'll start with is briefly introduce or define the Annotated Atlas. Then I'll move to say a few words who is intended for. Then some of the components of the Annotated Atlas will be briefly presented. A few words about the deployment of the Annotated Atlas, how it is deployed on other infrastructures, for instance, and then how it is linked to other WeaMyL components. To start with, first, so what is the Annotated Atlas? So it's a web browser based tools for searching through and analyzing weather warnings issued as common alerting protocol or CAP documents. The common alerting protocol allows emergency messages to be simultaneously disseminated over a wide variety of existing and emerging public alerting services. And CAP is kind of international and technical data specification. So if something happens in a region in Europe, for instance, and there is one country issue a warning, then all of the countries will get this information. Who is intended for? It's mainly for research meteorologists to ensure easy access to source observation data sets. So it provides quick access to historical warnings, but also to identify good training data for machine learning. So it's basically allows the researchers to navigate through all the previous or historical warnings and try to pick up some of the dates that can be used for training the machine learning algorithm, for instance. But once this has been done, on the other side, on the operational meteorologist side, it will be mainly used to analyze the weather warning proposal, to review any warning in terms of hit rates or intensity rates and the region where the warning was issued, and then also give the earlier warning some hit rate grades and update those rates if the warning is not that accurate. So it's quite flexible tool actually, and a lot of work has been done behind it, and you will see throughout the presentation all the details. Next slide, please. Yeah, so this is a schematic simplification of the different components of the Annotated Atlas. So you have in blue the different front end tools. In the middle, you have the back end with a green color, and then to the far right, you have connections to existing tools, or mainly to data services and data access and so on. So there are mainly two components. You have the front end, as I mentioned, and then you have the back end, something that you don't see, but it's running on operating systems. And just here, a brief summary, the main components of the front end, as I mentioned, are mainly user tools. These are also databases containing the data. and also CAP files. And in the back end, there are kind of search engines and ingesters and conversion tools that ensure the compatibility in transferring the data from a service to another, and how these how the front end and the back end are communicating together. Next, please. And then now comes more detail behind the Annotated Atlas component, and I leave it to Bart to continue with all the technical aspects.
Thank you very much, Abdulkadir. My name is Bart. I work at the Research and Development, IT Research and Development at Met Office in Norway. And so Abdulkadir has already shown you a good overview of what the system does. I think it's useful to follow the data basically from the user perspective, show you how you might search for data and how you might specify your searches and how you might retrieve data and then have quick look access to the data. So at the user end, we have a web-based client, the Annotated Atlas. Your searches are sent to the back end, which is this dotted line area, which is composed of a web server, the REST API, and a database. I've briefly mentioned why we've chosen what these components are, and it's the reasons that we've chosen these components are not that important at this stage, but I can always answer questions later on if you wonder why we've chosen this rather than PostgreSQL or some more traditional database, for example. So going on to the interface, this is what the user will meet when they visit the Annotated Atlas. You'll get a search parameter section where you can limit your search to phenomena, to various metadata that are stored in the databases, which are present in the CAP files. And this can be adjusted. We have configuration parameters that will allow us to include or remove various metadata from this search. But these are the basic searches that so far our meteorologists have given us feedback on and are interesting to include. So choosing an example of that would be phenomena, which are in the CAP files, and these lists are of course automatically generated from the database, from the current data. So here we see all the possible phenomena that are in the current data set. And choosing one of these and going on to do a search, we see that we've chosen rain flood for a given period and have now got 42 results. The results are listed up here very briefly. This section is sort of interactive. You can ask to see the original CAP file on which it's based, and there are other links to relevant data on threads, which we will see. It's also possible, once you've clicked on, if I may go back here, once you've clicked on any one of these data items, you'll get a very brief, quick look display on the map. This shows you the color of the warning and the region for which it's been issued. So it's a way of quickly navigating through the data and ensuring that you've picked the right data. If you click on the Sorry, I have to keep going back and forth now, because if you click on these triangles here, you'll see the original CAP data, which is retrieved from the database interactively. So if you wish to look at this data, it's an XML file, of course. It's not so easy to read and understand if you're not familiar with it. But if you're interested in programming, reading and analyzing this data, the XML data is available for that. Going back to the interface, we've now clicked on the arrow or the chevron that's next to the data set that we've chosen, and it will show us the data that is relevant to the search that we've made to the particular CAP file. This data has been fetched from another system, a REST API, which is another project, in fact, the Sender project, which is based on making data available through the so-called FAIR principles, this findability, accessibility, interoperability, and reusability, which basically is a system where data are cataloged according to internationally agreed metadata, and you can search through them. But these links are all links to the actual netcdf files on our thread server or your thread server, wherever it's been employed. And you can visit the thread server. This is an open service at the Met Office, and you can visit the thread server, and it will show you different portals into the data. This is an opened app form, which basically displays some opened app data, metadata about your data. Another view is the WCS get capabilities document, which again is used more for programming and programmatically accessing the data. Yet another view is the WMS capabilities, also for programmatically accessing the data and analyzing it, again on threads. Threads also provides Godiva, which is a sort of quick look visualization tool. And for the particular data set that we've been looking at, we've now chosen the equivalent reflectivity factor and done a little, and it does a little plot. It does a display. There are other ways of analyzing the data. This is all web-based, but if you choose to download the data, you can also do that, and then use your local tools for analyzing data. So something like NCD dump or NC dump, I think it's called in effect. You can either look at the data, extract the data in ASCII format, or look at the metadata as we're looking at here. There are also other tools that you can run. There's NC View, which you can run locally, and again, choosing the same variable, you can view the data, and you can choose a point on the data. I've chosen this point, I think, and get a plot. I should mention that there are many other tools. We basically use Linux for all our systems, both back-end and front-end. So you may not have exactly these same tools, but there are others I'm sure you're all aware of. There's Panoply, Integrated Data Viewer, and HDF View. These are all open source. I think they're all Java-based. These two are definitely Java-based, and that may also be Java-based. So going on within the interface, there is also the possibility of annotating the the CAP data. In other words, what Abdul Qadir was mentioning at the beginning, where the CAP warnings are evaluated retrospectively. And for that, you need to log in because the data is then stored back in the database. The original data is, of course, not touched. This goes into a separate database, but is associated with the particular CAP file that you've been evaluating. So you get a login area on the top right in the original image. I'll not go back to it. Once you're logged in, you get a message that you are logged in, and you can proceed to annotate. And this is the bottom right corner of the original view that I showed you. It will show you the current values in the CAP file in this column here. And some of them may be empty, of course, no value given. And you can then add your evaluation in these fields here and submit. So what's under the hood? Very briefly, this is the back end. This is part of the back end. This is the REST API. It's based on Python. It's called Fast API. It's a very efficient, nicely documented or self-documenting system, which uses OpenDoc as a standard. And it provides both this interface, this web interface, where you can test functionality and programmatic access. So if you click on any of these fields here, you'll get some examples of how you might use it from the command line using curl, for example, or Python, or whatever other language you wish to use, since it's a REST API. You simply access it through HTTPS, and you can retrieve the same data. So here you can test it. You click and say, well, give me a list. Up here it says, give me a list of all the phenomena in your database currently, and execute, and it will show you the current phenomena, which is what you saw originally in the first, or one of the first views I showed you with the drop-down menu of the phenomenon. It will also show you how you might access it using command line. It will also show you the actual URL, and you can use these to make your own programs. Most people use Python to communicate with the system. And the other component, the other major component in the backend is the database itself. It's a CouchDB, which is a non-SQL database. It simply is a collection of documents. Documents are normally JSON documents. We have chosen GeoJSON as the standard for representing the documents. And here we can see that warnings, these are the CAP warnings. There are some 14,000 documents. The system also has information about the local geography. Also, we have maps where we can search for regions and display those regions as polygons. And this system is in fact used by our own meteorologists to find relevant regions and issue the warnings. So in fact, before the CAP warnings are issued, the system is already used to find and locate, given a particular polygon, which counties or which municipalities are part of that CAP warning. And this is just a view of the actual data in the database. An example of it. This is a county, so county number 18 in Norway. Brief description, and there's basically a huge polygon below this that specifies the borders of that county. So this is the map part, which is already used operationally in our systems by the meteorologists. And if you view that GeoJSON document, in any, there are many mapping systems that simply will digest a GeoJSON document and display it. And that's one of the reasons why we have chosen GeoJSON, because it is so portable. So this is the county of Troms and Finnmark from the map database. And the CAP database is also, despite the fact that we have the original XML data, we represent the data, ingest the data, the CAP data as XML, and represent it as a GeoJSON object in the database, which can then also very easily be displayed with any standard tool. The reason we chose GeoJSON is that it is very portable and very easy to visualize in various tools. This is just an example of a website which is freely available. You can upload your GeoJSONs to view them. So whether they're map polygons or whether they're CAP files, you can, represented as GeoJSON, you can upload them and view them on a map. So finally, the deployment. This is an open source project. It's a project that was in collaboration between Norway and Romania, and everything is available on GitHub. These links are available. I won't click on them just now because there are, but you'll see when you visit these sites that they're very easy. It's all container based, Docker and Docker composed, so that to install the front end, which is Annotated Atlas, and the back end, which is the MECAP API, you simply run 2 or 3 commands from the command line, and your container should be up and running. And you can basically replicate what I've shown you on this slideshow. I must say that this has been very much a collaborative project. I have to particularly thank Sorin for his excellent work done at the Romanian Meteorological office, where he has installed all of this, and he's given us very valuable feedback along the way. Many hundreds of emails between Sorin and myself, and that's been very useful. So thank you for that. And I think I will hand the floor to, well, questions first, and then back to Abdelkader.